Cloud Tool Manager is a new feature that provides an easy-to-use interface based on web technology. The user interface is intuitive, graphic-based, and requires fewer clicks than before, simplifying the workflow for tool search, editing, and creation. Dynamic Tool Preview and Dimension makes it much easier to define and edit tools and holders in the NXCAM library. In addition, you can quickly and easily import tools from the vendor's database. The Create Tool dialog now contains the Retrieve Tools from Cloud Tool Manager option. The Cloud Tool Manager consists of three modules: Tools, Components, and Access Tool Vendor. There are four display modes: Card, List with Summary, Table, and Table with Summary. Each mode is independent and can be used with any module when searching, creating, editing, and deleting. We'll begin by editing an existing library tool and then adding that tool to the active part. Select the tool you wish to edit and click Edit. You may then edit the tool parameters and save the tool. The card for the tool has been updated. You may delete the tool as well. The search function allows you to easily find tools using the full condition mode by filling in cutting parameter fields. The search conditions appear in the ribbon above the tool cards that match the specified conditions. In this case, one tool matches. Clicking Send Tool to NX adds the tool to the active part. Next, we'll create a new tool. Click New, select the type and subtype, name the tool, and specify the parameters. A card appears in the Cloud Tool Manager for the new tool. Next, we'll explore the Components module. The Components module supports holders. You may select from multiple styles listed in the drop-down. Here we show the out-of-the-box holders. Specific styles are indicated by a label. This label is not indicated for generic holder templates. You may delete and edit holders in the Cloud Tool Manager. To edit, select the template and click Edit. Edit the parameters and save. The displayed card updates graphically. To create a new holder, click New, select the mounting style, name the holder, specify step parameters, and click Create. A card appears in the Cloud Tool Manager for the new holder. Like tools, holders can be sent to NX. Lastly, we'll explore the Access Tool Vendor module. Here you can easily access websites of tool vendors to obtain tools and send them to NXCAM. Once loaded, you may select tools from the catalog and send to NX Tool. The selected tool is previewed graphically, along with the name and description. You may import the tool to the NX library, or import and send to NX, which will add the tool to the active part. Here you can see the tool has been sent to the active part. Switching back to the Tools module, you can see the tool has been saved to the NX library.
This demo will take us through position part in machine context. Here we have our sample part, and today I'd like to show you the enhancements we've made in positioning this part on the machine tool. First of all, I need to retrieve the machine tool from the library. For this example, I'll take an out-of-the-box Simo 1 machine kit. The previous enhancements have been around turning the machine tool on and off completely during position of the part for the part mount junction, as well as changing the translucency of the machine tool to enable the user better visibility while positioning the machine tool. I'd now like to show you the enhancements in position part on machine. As you can see, we now have the option to create a bounding cylinder or a bounding block around the component. So in this case, I can select a bounding cylinder. And you'll also be familiar with this dialog from the MCS view, where the user can now select in the dialog, and it updates the thesis on the component. From here, the user can then interact directly with the machine tool, placing the part in different positions on the bed of the machine. I can now press OK, and we'll see the machine tool has now positioned. The part has now been positioned on the machine tool in that position. The second thing I would like to show you, if I turn on some fixturing, like the chuck and fixture plate, and now when I pick a machine tool, this time we pick a slightly different variant of machine. Again, I'll specify position part on machine, and now I can select the bounding box, and we can see as I move this around, it's also incorporated all the fixturing as well as the part to a positioning on the machine tool. Once again, I can pick dynamically in the dialog, and then once I've picked on the dialog, I can then specify a position on the machine tool to center it correctly, and then rotate. Once again, pressing OK will position the part on the machine. And finally, I'd like to do the same, but I will show you in a different kinematic. So this time I will turn off the fixture plate. Again, select the machine tool. This time I will pick a mill turn, so the Sim 15 is numeric. Okay, again I can rotate the machine to get a better view of where the part is. Again, I can use position part on the machine. This time specify the cylinder, pick the front face, and I can move the part and the chuck out. So I can pick the rear of the chuck in this dialog here, and then I can snap to the correct position on the machine tool. I could rotate if necessary, but press OK. And that was the enhancements in position part in machine context.
This new feature provides automatic holder shape computation of turning assembly tools for collision checking. You no longer need to specify collision shape and layer settings manually during tool creation. If user-defined collision geometry has been defined, then the user-defined collision geometry is used. The automatic holder shape computation will be used only if there is no user-defined collision geometry specified. The operation must be inside a turning method object, and collision settings check must be set to insert and holder. We'll begin by looking at the tool assembly. If a holder shape has been defined, as in a legacy case, the system uses the specified 2D shape on layer 3 during toolpath generation for collision checking. Notice in this case, there is no user-defined collision geometry specified in layer 3. With no user-defined collision geometry specified, the detection of the tool holder collision for assembly tools is now computed automatically and displayed graphically when you generate the toolpath. A message displays informing you of the collision between the IPW and the tool holder. The names of the colliding pairs are displayed. You can now define multiple-step shanks by extracting shank data from 3D parts in the same way that holders are currently defined, making complex multiple-step shank definition much easier. You can also save and retrieve the shank in its own individual shank library, or save and retrieve it with the tool to the tool library, avoiding redundant shank definition and making shank management easier. Displayed here is a solid body, from which we will extract the step parameters to create a new shank. Profile start position is the distance from the shank positioning point to the tool tip. This value is used to position the shank on top of the tool and generally equals the tool length. The Extract Step Parameters option is new. The multi-step shank is created using the same step parameters as the selected body. The steps appear in the list. Next, we'll export the multi-step shank to the multi-shank library. Now we'll retrieve the exported multi-step shank from the multi-shank library. The shank we created and exported to the multi-shank library has been retrieved and used with the chamfer mill tool. Next, we'll export the tool with the multi-step shank to the tool library. Lastly, we'll retrieve the tool from the multi-step shank from the tool library. The following caveat applies. Extracting step data from 3D models only supports extracting data from one part. It does not support extracting data from multiple parts. This enhancement introduces a new Dovetail tool subtype, greatly simplifying tool creation by allowing you to easily specify basic Dovetail tool parameters. To create a new Dovetail tool, you must use the Mill Planar, Mill Contour, Mill Rotary, or Mill Multi-Axis templates. The Dovetail Mill subtype is new. Specify tool parameters as you would with any other tool subtype. Saving and retrieving from the tool library is also supported. OK completes the Dovetail tool creation. Dovetail tools support the following operation types: planar profiling, planar mill, Z-level undercut, 3-axis deburring, solid profile 3D, and profile 3D. You can now measure the distance between 2 points on a toolpath and the distance between a point on a toolpath and selected geometry. First, we'll measure the distance between 2 points on a toolpath. The system displays the minimum distance between the two selected points. Next, we'll measure the distance between a point on the toolpath and a face on the part. The system displays the minimum distance between the point and the face.
This recording will take us through enable geometry reuse between operations. This is where we extract operation cut area. In this part we can see we have lots of complex surfaces where operations are required to specify the surfaces that need to be machined. Currently the workflow users have to take is to create a mill area, and from within that mill area they can select multiple geometries, and under that mill area they can specify the operations that want to reuse the same cut area. However, some users find that they create an operation and then decide that they want to keep the cut area but change the type of operation. Currently they would have to reselect that geometry again, or if they would like to use a subsequent operation using the same cut area that's a different operation type, again they would need to reselect that geometry. What we've enabled is that an operation such as this tube mill, which has a cut area defined inside this port, and would like to reuse it for other operations. Now what you can do is go to the geometry view, right mouse button on the operation. Under objects we can now select extract cut area. This is the new capability. When the user selects extract cut area, a mill area geometry object is created under the same workpiece that the parent operation was under. You can also see that the mill area takes the name of the operation that has extracted the mill area. If I go into the mill area, you can see the cut area that has been extracted, and you can then see how we can use other operations to drag and drop and reuse that mill area. The capability will enable you to extract the cut area more than once. So if you want to extract it and then extract it again and make some changes to the selection, you can do. So the second selection, I can go around and deselect a single face, deselect another face, and we can have a different selection area. You're also able to select multiple operations at the same time that have areas that have cut areas selected in them. You can right mouse button, object, extract cut area, and we will get multiple extractions. And you can also select operations that do not allow cut area, and you will notice that in these operations the extract cut area is not available under the right mouse button object. If you select multiple operations that include operations that do have cut area and those that do not, you will see that when the extract cut area is not available. If you extract a cut area from an object that does not have cut area, such as these here, you will get a message to say that the following operations do not have geometry defined. Again, if you do a mix of operations that do and do not have cut area selected, the extract cut area is still visible, The ones that do have cut area will be visible in the Operation Navigator. The ones that are not will have a message to say that there was no cut area defined. The only thing that needs to be taken note of here is that this is only available in the geometry view, and it is only available on operations that support the selection of cut area within the operation type.
Welcome to NX 2306 Multi-Axis Additive Manufacturing. In this video, we're going to take a look at the new enhancement in the new drive style, medial axis and auto center point. The medial axis of a part is basically the middle of the part, or an axis slicing the middle of the part. So if I go to my operation here, and when I go to main, you give it your part as normal, you give it your foundation face as normal, but when you go to specify drive geometry, you can say curve or surface like normal, or you can say auto center point or auto medial axis. You don't have to pick a drive curve or a drive surface. It automatically creates the medial axis or center point to use this operation. So I say auto medial axis, click OK. In this case, I'm not using infills and finish passes. I'm using infills only. And I'm also extending the drive. So the medial axis is essentially the curve that's in the middle, and then it offsets that curve and gives you a nice infill pattern. This gives you a new alternative to filling parts other than just using zigzags or some other round and round spiral motion. Now if I do the same operation but with the finish pass, so I go to strategy and say infills and finish passes, here we can see the medial axis and the finish pass. Now if you go to your medial axis and in strategy you tell it to not extend drive, so the medial axis is your drive curve. If we say don't extend the medial axis, then you'll get something like this. The medial axis is the curve that's in the middle, and then it does this kind of race tracking motion outwards from there to fill in the part. And here's the same with a finish pass, not extending the medial axis and with a finish pass. Auto center point, on the other hand, automatically finds the most central point of the part and then does a round motion from outside of it. So if I go to auto center point, for specified drive geometry, instead of medial axis, you say auto center point. It finds the centermost point of the part and does circular motions outside of it. Now instead of concentric circles like we have here, you can tell it to do spirals. So you can say auto center point, and for a cut pattern, instead of zig or zigzag, use spiral and get an output like we have here. The auto center point can be especially useful on round type parts. So it finds the auto center point and does a spiral motion around to fill the layer. Or in this elliptical point, it does a spiral as much as it can and then fills in everything else with a trimmed round portion. Auto medial axis and auto center point give you new ways to fill the part that can give you less voids and create a better output. But it's not applicable to all parts. You're going to have to test the part yourself to determine which ones work best. We give you this as a new option to be able to fill parts more efficiently in some situations. Thank you very much. Welcome to NX 2306 in multi-axis additive and the new enhancements for the new release. In this video, the first enhancement we're going to talk about is the extra tilt function. We've added extra tilt to other operations, such as freeform buildup, but now we've added it to the tube operations. Let's take a look. If I have the output on this tube, notice that the tool is tangent to the surface at that point. That is with no extra tilt. So if I'm using the tool axis, align tilt from curve, there is 0 additional tilt. However, if we look at a similar operation with all the parameters the same except for the additional tilt angle, in this case 30 degrees, what we'll see is that at each point, the tool will be tipped away 30 degrees. This is especially helpful for powdered metal DED processes where you want to make sure the metal is attaching correctly to the part without excess loss. So extra tilt has been added to the tube functions, tube thin wall and tube additive buildup with the finish passes. Thank you very much. Welcome to NX2306 Multi-Axis Additive Manufacturing, and in this enhancement we're going to look at smooth cylindrical clearance. Typically, if I was to create operations for these bosses, it would traverse from one boss to the other in a straight line, and we can see that here. Now I can make it have smooth traversal moves by turning on smooth and smooth transfers and rapids, and recalculate that. And we can see those smooth movements. However, what I would prefer to do is have the traverse movement also be along the cylindrical clearance base. Okay, we can do that now by using a bounding cylinder. So I'm going to make sure I say bounding cylinder for my common clearance. I give it a rather large region distance because jumping this gap here is fairly large compared to the tool diameter. But also, when you go to your transfer rapids, for your traverse, you're going to say smooth instead of the other options. So what you'll get instead is traversal movements that are more cylindrical and rounded with the part. The reason this is important is if you're going to run this on a machine with a rotating table. So if we look at the first operation and we do a machine simulation, we can see that we're not using the rotating table at all in this instance, and it's doing mostly just 3-axis moves. However, if I look at the second operation, where I'm forcing it to be cylindrical, I'm also forcing it to be rotating around that cylindrical axis on the machine. So if we simulate this one, we'll see that we're allowing this C-axis on this particular machine to do the majority of the work without the head moving around in X and Y. This creates a smoother movement and it creates smoother output for the machine and the controller. So again, this is smooth cylindrical clearance to control the traversal movements on round parts. Thank you. Welcome to NX2306 Multi-Axis Additive Manufacturing. And the enhancement we're going to talk about in this video are spring pass power levels. Previously in the UI, you could give it a power level per layer. So if I go to my power levels button, you can see I have laser power here, and from layer 1, 2, 3, and 4, the laser power is 2000. Layers 5 and up, the laser power is 1800. What we've added is the ability to give a separate spring pass power level for the same layer. So if I expand the box, we can see that I also have a separate column for spring pass power laser. So in this case, I can use a different power level for spring passes than what we use for all the other passes on the level. And this becomes important because users wanted to have either more or less material deposited on the spring passes than they did everywhere else on the part. So we needed to be a way to control the power levels for the spring passes. Simply just give it the layer number and then the values for the laser power and the spring pass power, and then you're good to go. This is useful for people who are using spring passes for all technology types, which allow you to a lot of times help build up where you have a little bit of deformation. Thank you. Welcome to NX 2306 Multi-Axis Additive and new enhancements. In this enhancement, we're going to take a look at smoothing options for between regions and within regions. First, if I create an operation on this part, we have a fairly sharp corner here. And sometimes in sharp corners, it would deposit too much material as the tool slows down or the machine slows down in that corner. So one of the options that we can do to control that is to automatically break the corner. If I look at this operation here and I go to corner detection, you can see I can replace the corner with a non-cutting move. So in this case, it took the corner out and it replaced it with a non-cutting move. And we see that here. So effectively what's happening is we're not depositing material in the very tip of the corner. And because of that, we're not over depositing material. Now this operation uses standard NCMs, meaning the smooth is not turned on. Smooth connections is not turned on, which means that when you go to transfer rapid, you have both the between regions option and the within regions option. And that becomes critically important to what's going to happen next. Now if I actually do it with the smooth on, meaning I override with smooth connections, you notice when you go to transfer rapid, you have between regions, but you no longer have the within regions option. So some of the control for within regions is not available to you. And that might be a problem for what we're doing here. So we can see the default smooth that you get for the corners actually lifts up along the tool axis a fair amount. So what we've done is we've put the option under non-cutting moves, the smooth within height, this value here, we've put that into the UI. So that controls the smooth height for within regions, not between regions. Smooth height here is for your between regions. Smooth within height is for your within regions area. And in this case, you can see we use 25% and it lifts up a lot less than the previous operation did. And if I go with 0% on my smooth within height, you can see that those NCM moves in the corner are nice and smooth and they're not lifting up. This can give us a smoother operation on the machine with less vibration and less gyration. So again, you have the option when using smooth connections, override with smooth connections, you now have a variable or option you can put in for a smooth within height versus just a between height, which is what you normally had. Thank you.
We start the demo to import prime turning tooling data from a tool vendor. You can import vendor catalog data from the ML dashboard. Under New, choose Import Vendor Products. From here you can select the vendor package and click Upload. Teamcenter automatically detects the file types. The system supports vendor packages based on the DIN and GTC standard. Once the package is uploaded, choose Map Vendor Product for an automatic mapping into the new customer tooling structure. There's another option allowing to import 3D models provided by the tool vendor. The system shows the status while the vendor data is processed and presents a summary once the step is finished. For this example, we imported prime turning components from Sandvik Coromant. There are two prime turning insert types supported. Here you can see a type A insert shape with all the necessary attribute values provided by the tool vendor. Additionally, we implemented specific tool holder classes for the prime turning tools, supporting the different required machine-side connections. Following the steps to build a prime turning tool assembly. We add the first component by selecting the prime turning insert we just imported from the tool vendor. Now we can add more components using the function matching components. The system will guide you and list only other components that fit to the selected component. In this case, you can select a tool holder that fits perfectly to the selected Type A insert. The holder is added to the assembly structure. Let's continue to add more components. In this case, select the tool holder and matching components will list all the available machine adapters that fit onto this holder. The assembly structure is now complete and you can verify the 3D tool assembly. The system automatically positions the prime insert and holder into the machine adapter. We have just moved components in Teamcenter. For the next step, we will prepare this for tool retrieval in NX CAM. We use the command create NX assembly. This will create the NX assembly part file and calculate some tool parameters, for example, the tool tracking points. Now I can simulate the NX tool retrieval directly here in the web user interface. The command check NX CAM tool retrieve will verify if all tool parameters are correct. The tool is now prepared and can be used in NX CAM to generate prime turning toolpaths, and the 3D model can be used for toolpath simulation. Active Workspace arranges tiles on the home screen to provide easy access to the various functions. This home screen is called a workspace. You can switch between different workspaces. The default workspace is loaded with an overwhelming number of possibilities. A lot of them are typically not used by the manufacturing user. This is why we now offer a specific workspace for the manufacturing users. The manufacturing workspace offers a clear layout allowing you to concentrate on your daily task. It is easy to find the most important commands on the main screen. This workspace also includes tiles to directly create manufacturing objects, so the planning user or the NC programmer can quickly initiate new jobs. You can, for example, easily create an NC machining operation to manage a CAM setup. This can be used with the part manufacturing web user interface or sent to NX CAM to be filled out in detail. You can initiate a job task for additive manufacturing to plan a job file for 3D printing. An inspection operation can easily be created that can be used in CMM or NX metrology. The manufacturing user can also design a new CAD part that can be used to manually build an in-stage model. And there's a lot of other use cases for this function. Using Create Resource, the tool engineer can quickly initiate a new resource item. For all the create operations, you can select the desired item type to specify what object should be created. Now you have a good overview of the manufacturing workspace.
Cards. Driven by digitalization.